All right, here's another problem. This one is also about electric potential energy, problem number 7. So this one says, what is the electric potential energy of the group of charges shown in the figure? So as you can see there, we have two positive charges, one negative charge. The distance between them is given. And notice that this problem is about calculating the electric potential energy. So this is about energy, the potential energy, electric potential energy of the group of charges. So these three charges, the system composed of three charges, has a total amount of electric potential energy. There's energy stored in this configuration of charges. So how do we calculate that? So first of all, we're going to start by labeling these charges. So 1, 2, and 3. And you might recall from the videos that when we have a system of charges, the total potential energy, it's the sum of the potential energy of all of the different pairs that you can construct out of the charges of the system. So I suggested that you label the charges, then just write the numbers 1, 2, 3, etc., as many charges as you have, and then link them, the numbers, right, just so that you can count and see clearly which pairs of charges you're going to be adding to the total electric potential energy. So we're going to need a pair, the potential energy of the pair 1 with 2. We're going to need the potential energy of the pair 1 with 3, and the potential energy of the pair 2 with 3. That's all the different pairs that we can construct out of 3 different charges. So the first term, 1 with 2, so potential energy of 2-point charges is K, the electric constant K, times Q1 times Q2 divided by the distance between these two charges, which I'm calling here R12. We're going to add to that K times Q1 times Q3 divided by the distance R13. And we're going to add to that K times Q2 times Q3 divided by the distance between 2 and 3. All right, so what are the numbers that we're going to be plugging in? So for Q1, we're going to plug in 3 times 10 to the minus 9 coulombs, because that is 3 nanocoulombs. For Q2, we're going to plug in minus 4 times 10 to the minus 9 coulombs. And for charge 3, we're going to plug in 3 times 10 to the minus 9 coulombs. The distance between 1 and 2 is 3 centimeters. Remember that we have to use MKS units, International System units. So we're not going to plug in 3, we're going to plug in 3 times 10 to the minus 2 meters, because every centimeter is 10 to the minus 2 meters. For the distance between 1 and 3, we have to do a little bit of trigonometry, or I guess geometry here, because the distance between 1 and 3, as you can see there, will be the hypotenuse. There is a triangle here, right there. Triangle form here, right angle triangle form by these 3 charges. Sorry, that doesn't look very straight, but anyway, this is the hypotenuse. So the opposite side is 3, the adjacent is 4 centimeters. We're looking for the hypotenuse. So that's what we have here, square root of opposite side square plus adjacent side square, square root of that, and it's going to be in centimeters, so that is 10 to the minus 2 meters. So as you know, that's a 3, 4, 5 right angle triangle. So the answer is 5. The distance between 1 and 3 is 5 centimeters, or 5 times 10 to the minus 2 meters. Finally, the distance 2, 3, which we're going to need for the total energy calculation, is going to be 4 centimeters, or 4 times 10 to the minus 2 meters. So the first term in our potential energy will be the electric constant, so we're going to round it to 9 times 10 to the 9. And notice that I already, all the units, I always make sure from the beginning of the problem that I write them in MKS units. So I'm going to skip writing the units because I made sure that all the units are MKS, so I know that the result of this calculation is going to be joules. So K constant is 9 times 10 to the 9, multiplying by Q1, which is 3 times 10 to the minus 9, multiplying by Q2, which is minus 4 times 10 to the minus 9, and we're dividing by R12, which is 3 times 10 to the minus 2. The second term is K constant, 9 times 10 to the 9, Q1, again, 3 times 10 to the minus 9, and Q3 is 3 times 10 to the minus 9. the distance that we need to use now is between 1 and 3, and that distance is 5 times 10 to the minus 2 meters. The last term is, let me show you here, the last term is going to be K, this electric constant, times Q2, so minus 4, Q3 is 3, so K times minus 4 times 10 to the minus 9 times 3 times 10 to the minus 9, and divided by the distance between 2 and 3, which is 4 times 10 to the minus 2. And plugging in all those numbers, for the first term, we can see that 10 to the 9 and 10 to the minus 9 are going to cancel. There's a 3 in the numerator that cancels the 3 in the denominator. And for the first term, we get 9 times 4, which is 36, so minus 36, notice the minus sign, minus 36, and 10 to the minus 9 divided by 10 to the minus 2 is 10 to the minus 7. So that's our first term. Second term, again, 10 to the 9 and 10 to the minus 9 cancels. The numerator is 9 times 3 times 3, which is 81, divided by 5, the 5 in the denominator, and the this multiplied by 10 to the minus 7, because we have a 10 to the minus 9 in the numerator and a 10 to the minus 2 in the denominator. The third term, as you can see there, the 4 in the numerator and the 4 in the denominator cancels, 10 to the 9 and 10 to the minus 9 cancel, and you end up with 9 times 3, which is 27, and times 10 to the minus 7. And all of these terms, every term here is a unit, will have units of joules. So we have minus 36 plus 81 over 5 minus 27, and that number, the final answer will be that number multiplied by 10 to the minus 7. So if you plug in that in your calculator, you will get minus 46.8 times 10 to the minus 7, and the best way to write this in scientific notation is to move the decimal one place to the left, and we can round this to two significant figures to get, because notice that the numbers were given with two significant figures, so minus 4.7 times 10 to the minus 6 joules is the final answer for this problem. Alright, see you in the next video.